Today's presenters are Herb Schoeneman, Nora Crivello, and Kevin Fernandez. You may remember Herb from our last webinar on package integrity testing. Nora is the Vice President of San Jose and has been with Westpak for 12 years. Kevin is our Quality Manager and has been with us for 8. Nora, take it away.
Good afternoon, everyone. We're so grateful that you joined us this afternoon for our webinar on writing package validations with ISO 11607 and speed to market in mind. Kevin and Herb and myself will be commentating for about the next hour, so join along. Feel free to ask any questions as we go. Kevin, away to you.
As a test lab, we do a lot of package validation testing. We see and execute a lot of these package validation protocols for our clients. So that means that we do the climatic conditioning, we do the package performance testing, the accelerated aging, the bubble, the peel testing, the burst testing, pretty much all testing that you need to do in order to properly validate your medical device package system. So we do have a bit of experience reading and executing these protocols, and sometimes we run into issues in the way that these protocols are written. Not that they're bad or wrong, but there are some things in the protocol where a little more clarification and detail would make the whole testing process go a little smoother and minimize any potential delays, and ultimately minimizing your time to the market. With most companies, time to market is important, and the package validation can be critical with this, since packaging is often one of the last steps in this whole process. So the point of this webinar is to offer some tips and suggestions when it comes to developing your package validation protocol. There are some things to be aware of when you're writing your protocol in order to make it go as smooth as possible with testing, with your test lab, and with the FDA, which again ultimately reduces your time to market. So here is our agenda for this webinar. We're going to briefly go over a description of a packaging system, the FDA requirements, ISO 11607, common sections in a validation protocol, common issues when developing your protocol, what to look for when choosing a test lab to execute your protocol, and how to work closely with your test lab to minimize time to market. Just so we're on the same page, I'm going to briefly go over a definition of a packaging system. For medical devices, a packaging system comprises of a sterile barrier system and the protective packaging. The sterile barrier system is typically your primary package. This is your package that is in intimate contact with your product and provides the sterile barrier. This is the package that allows for sterilization and provides a microbial barrier. So these are usually your breathable pouches and trays, which is most commonly a spun polyolefin material, also known by its trade name as Tyvek. Then we have the protective packaging. This is your secondary and tertiary packaging. This is the packaging that actually contains and protects your primary packaging. So these are your cartons, your shippers, or whatever your package configuration may be. Herb, did you want to comment on this?
Thanks, Kevin. This is Herb Schoeneman. I want to welcome everyone to our webinar. Kevin's points are exactly right. These are the primary areas of concern when looking at packaging systems for medical devices and similar. I want to emphasize that they're not the only package functions. There are many more. Traditionally, there were 4 of them taught to us in the dark ages when I went through the curriculum at school, and they're added and subtracted by various authors since that point. But these are the primary ones that seem to be very important for medical device and similar product and package validations, and that's why we're focusing on them. I just want to make sure everyone's aware that we're not trying to say these are the only package functions. They're simply the ones we're focusing on right now. Kevin, back to you.
Thanks, Herb. So that's what we're going to be focused on, the entire packaging system, and it's that entire package system that must be validated for clearance by the FDA. So I'm going to briefly go over what the FDA is looking for when we're validating this. So obviously validation is one of your critical steps when it comes to getting your product to the market. And this is going to be based on FDA requirements for 510K submission. So what are they looking for exactly? And what they're actually looking for is pretty straightforward, but it's also a little vague at the same time, since they don't actually provide too much guidance on it. The FDA pretty much says that the package system must provide adequate protection against damage during shipping and must maintain sterility of the device for the duration of the shelf life. And they say to prove this with a package validation, or to prove this package validation with testing. Prove that your package can withstand the shipping and distribution environment and maintain sterility. So this should comprise of your distribution simulation testing, your sterile barrier system integrity testing, and an aging shelf life testing. But again, they say to do this, to prove this, but they don't provide too much guidance on exactly what needs to be done specifically. But they do suggest following ISO 11607, and being compliant with 11607 wouldn't actually satisfy the FDA requirements, and that's what most companies do. ISO 11607 is the guidance document or the standard for validating sterilized medical device packaging, and being compliant with this should provide enough proof that your packaging satisfies what the FDA is looking for. It'll show that your package allows for sterilization, it provides effective protection, and it can maintain sterility up to the point of use. It's also an FDA recognized consensus standard, and it's required for European regulation in order to get a CE mark, so it's no wonder most companies use 11607 just for this. But even then, ISO 11607 is still just a guidance document. When you actually read through it, you'll see that it gives you all the requirements that need to be satisfied, but it still gives you a lot of different options and suggestions of how to satisfy all of the requirements. It still doesn't tell you exactly what type of testing you need to run. So this is going to be up to you to decide and to document in your internal validation protocol. It's your protocol that's going to have the specific test plan on exactly how you're going to prove that your package systems satisfies the FDA's requirements. So this is what we're going to be talking about today, your validation protocol. I'm going to briefly go over some of the common packaging validation protocol sections. It's not to say that these are all of the sections that are mandatory for a protocol or that these are the only sections you need, but these are just some common sections as it applies to package validation. I'm going to go over some of these sections briefly and then dive into a little more detail on certain sections where we may have some helpful insight for you. So real briefly, the purpose section of your protocol, this is where you state the reason for your protocol. The scope, this is the extent of what your protocol applies to or what it deals with. The responsibilities, this is where you state what parties are responsible for executing what section of the protocol. The sample preparation and information section, this is where you can put the details of your package configuration, if it'll contain live or dummy units, maybe numbering or testing designation, whatever else might be important to you here. The sterilization section, this is where you can put details of sterilizing following the packaging and prior to testing, and any information here that will be important to you as it applies to sterilizing your samples. So these are the sections I just wanted to mention briefly. For the next sections, I'll go a little deeper with some suggestions. So the first section that I like to talk about is reference documents. In this section, this is where you're referencing industry standards or SOPs. These are the documents and the methods that will need to be followed in order to execute the testing in your protocol. And an issue we often see here is referencing old versions of industry standards. So if you're going to put revision dates here, we recommend making sure that you call out the correct and the latest revision for these standards. Usually industry standards don't get revved very often, and when they do get revved, it's not at a regular interval. So you really need to do your homework and see what the latest revision is. If you're actually unsure of the differences between different revisions of certain standards, I would suggest asking your packaging test lab. A good test lab will know the newest revision, and they should know the changes compared to previous ones. So another thing to add is if you're going to reference internal SOPs, be sure that your test lab has these SOPs as well. These standard operating procedures for your company may have very specific test parameters that the packaging test lab needs in order to conduct your testing properly, and not providing this SOPs can cause delays or even a deviation. So make sure you provide this to your test lab as well as the protocol. Herb, did you want to add something in on this?
Thanks, Kevin. At the risk of sounding like a broken record, I do want to make sure that our seminar attendees realize that this is one of the most common pitfalls that we see in specifications, not calling out the correct revision number. And any auditor is going to catch this and not be happy. And we all know that happy auditors make our lives much easier. So make sure that you keep a really close eye on this. One of the techniques that we've seen that we highly recommend is to not even reference revision numbers when you call out other documents within your protocol, but simply say latest revision, and then you don't have to worry too much about it, and it's not going to get caught or flagged by an auditor. So just a suggestion. Again, that's one of the things that we've seen the most as far as pitfalls, and we'll be talking about this more later. Kevin, back to you.
Thanks, Herb. The next section I'm going to talk about is sample size. And this is a question we get asked a lot, and as we know, this topic can be a webinar on its own, a workshop, or even a semester class. So I'm not going to go too deep into this topic in the interest of time. A lot of companies usually have a specific sample planning documentation or standard operating procedures that provide the sample size and rationale. So if you have that and you're able to reference it and it's applicable to what you need, then I suggest using that. But oftentimes clients don't have this information and they ask us for guidance. If you ask a statistician about this, the answer they usually give you is it depends. It depends on the confidence, the severity of what you're looking for, how conservative you want to be, what your process is, whatever. It just depends, and usually that isn't too helpful. So when people ask us this question, for this type of package validation testing, I'm sorry, our recommendation would be 59 samples for 95% confidence and 95% reliability in the absence of other data. This is based on attribute sampling, so that is a total of 59 sterilized units or primary package. If you want more detailed information on this, we can assist you with the rationale offline if requested. Herb, is there anything else that you wanted to speak on about this?
Yeah, thanks, Kevin. As Kevin pointed out, it's one of the most common questions that we get a lot of. We did touch on this briefly during a previous webinar, so if you want some brief information without talking to a real-life person, you can go to our website, www.westpak.com, and look for the webinars. And the one held in September of this year does briefly talk about the 95-95, sample size, attribute, quality level, all that kind of stuff. And what are the sample sizes for like a 90-90 or 85-85? And it's straight from statistics, and a lot of the background information is given there. So this is a little bit of help there. Thanks, Kevin. Back to you.
Thanks, Herb. The next section I'd like to touch briefly on is the equipment section. This is the section that addresses the equipment that will be used for testing. You can be as detailed as you want to be here, but since you really don't know exactly what equipment and associated instrumentation that your test lab will be using, I would recommend just keeping this section general. Just state that the equipment used will be in current calibration and will be traceable, and that the test lab will provide identification of the equipment and calibration dates in their final report. So I would just leave that at that. So on the actual testing portion of the protocol, package integrity testing, also known as package performance testing, distribution simulation, transit testing, or even shake, rattle, and roll testing. This is where you're going to outline your test sequence for the testing that's going to challenge your packaging to the shipping and distribution environment. This is where you bring the worst case scenario, real world, into the test lab and subject your packaging to it. Industry standards are usually referenced for this testing, and common procedures are ASTM D4169, ASTM D7386, different ISTA procedures such as 2A or 3A, or even a custom test sequence that your company may have come up with. These shipping simulations usually consist of climatic conditioning, drop testing, compression testing, vibration, concentrated impacts, and low pressure testing. And Herb, did you want to comment on this?
We're often asked this question about this kind of protocol, and Kevin's advice is good here. The two ASTM standards referenced are probably the most common that we see. ASTM is now called ASTM International. It used to be American Society for Testing of Materials. Is a consensus organization here in the United States, and is over 100 years old, has been publishing these standards, and they're well recognized, so there's nothing wrong with them. ISTA, the International Safe Transit Association, is also a well-established organization, but until recently has not really published standards that were recognized as consensus. They had a committee that put them together, and they were every bit as good, but the FDA kind of had a qualms about it. We understand that is changing rapidly, and so very shortly we anticipate that ISTA procedures will also not wrinkle the nose, if you will, of the FDA. So a lot of changes going on in this area. One of the things that you can rely on with a good testing laboratory, and we kind of put ourselves in that category, obviously, is that we keep track of that, and we keep our nose to the ground, if you will, our ear to the ground, and nose to the grindstone, whatever that is. So we try to take that burden off of our clients, keep track of what's going on in the standards, which ones say which. So that's why we make these recommendations. They simply seem to work best for our clients. Kevin, back to you.
So a lot of clients will actually ask us what test sequence they should use for their product, for their packaging, which standard is best. And for the purpose of medical device package validation testing, our recommendation would be sticking with what's on the FDA approved list. And right now, for package testing, the FDA recognizes ASTM D4169 and D7386. So we would recommend going with either of those test sequences for the time being. These are, like Herb said, these are consensus standards. These are based on empirical data to back up the test sequences. They're FDA recognized, so there's going to be less questions from the FDA if you go with either of these, so they're a pretty safe bet. That's not to say that these standards are better or worse than ISTA's test procedures, but the ASTM ones are recognized by the FDA, so it's our recommendation. In either case, D4169 or D7386, the procedures actually have many options to choose from depending on your packaging and your expected distribution environment, but there are standard sequences that are commonly used. If you actually need assistance with what test sequence to choose, I would, again, consult your packaging test lab. A good test lab should be able to give you a good recommendation based on your package configuration and purpose of testing. So that's our recommendation for now. Just stick with whatever is on FDA's approved list. And like Herb said, we may have some changes in the future with ISTA, and we may have more options. But for now, we would just say stick with D4169 or D7386. So the next topic I'm going to go into is shelf life testing or aging. The FDA and ISO 11607 says that you must prove that your packaging will maintain sterility throughout distribution and throughout its intended shelf life. So real-time aging is required. But it says you could run accelerated aging in parallel in order to get your product out to the market without having to wait that 1, 2, or 3 years of real-time aging. So accelerated aging, this is accelerating the adverse effects of aging by storing the samples at an elevated temperature for a certain amount of time, and this will be equivalent to a certain shelf life at normal temperatures. So what usually happens is the samples will go through a distribution simulation testing, then aging, then a sterile barrier testing to evaluate this for any sterility breaches, and this should prove that your sample can maintain sterility throughout its intended shelf life. A question we get asked often is what accelerated aging temperature to use. And accelerated aging follows ASTM F1980. This is based on the Arrhenius equation, which shows that an increase in temperature increases molecular activity in a material, which in turn speeds up the adverse effects of aging. So time and temperature, the time and temperature to use is going to be based on different variables. These variables are aging shelf life, real-time temperature, aging temperature, the Q factor, which are all defined in ASTM F1980. In a few slides, Nora is actually going to go into a little more detail on manipulating these factors. But the bottom line is the higher the temperature you use, the faster the aging. However, the caution is that you don't want to go too hot because you may actually damage your product. So our recommendation is go ahead and speed up this test with a higher temperature, but you only want to go with a temperature that your packaging can safely withstand. And usually 60 to 65 C is usually a safe upper limit. But the bottom line is you should know your product and your packaging characteristics and avoid any temperatures that would damage them. Herb, you want to add to this?
Thanks, Kevin. A question that arose during our earlier webinar on the same topic involved the use of humidity with the temperature in an accelerated aging process. And at that time, we simply explained that the Arrhenius equation on which this whole accelerated aging is based simply states that molecular activity, particularly in organic molecules, is a function directly related to temperature. If you double basically increase the temperature by 10 degrees C, you double the molecular activity of organic molecules. There's no mention of humidity's effect, and we've seen that as well. We do offer accelerated aging conditions with humidity, but the trend is vastly away from that. It's a difficult thing to do. It's an unknown variable, quite honestly, in the equation, and there's a bunch of other issues that can negatively affect and kind of cloud what you're really trying to do. If anyone's interested in that effect, we'd certainly like to talk to you. So email us your comments, concerns, or questions. But for the purpose of this webinar, we want to emphasize that humidity does not have a validated effect or a noted effect in aging, and it is not referenced in any of the standard documents. People do question it, but that's our standard answer. Kevin, back to you.
Thanks, Herb. So following the package performance testing and following the aging, you want to evaluate your sterile barrier to make sure that it didn't develop any breaches during all of that testing. Typically, bubble testing, dye penetration, and or visual inspections are used to do this. ISO 11607 also says that you need to demonstrate adequate seal strength of your pouches and trays. So typically, peel testing or burst testing is done for this. We've seen many protocols in the industry, and a lot of times companies will call out either visual inspections, bubble testing, or dye penetration testing, or some combination of the three. And our recommendation wouldn't, or we wouldn't solely suggest relying on visual inspections for your integrity evaluation. Visual inspections based on F1886 really are just for evaluating the seals of the package, and it only has a defect rate, detection rate as low as 60%. The human eye can only see so much. We also wouldn't suggest just going with dye penetration testing, because that really is for just evaluating the seals of your pouch or tray. It doesn't test the surface of your package, and it really is only appropriate for seal validations. Gross leak detection or bubble testing would be more appropriate, I say. It's a test. It tests the entire package. It tests the seals and it tests the surface. Our internal validation with ASTM F2096 here at Westpak showed greater than 90% detection rate, so this is the testing that we suggest for this. As far as demonstrating adequate seal strength for your pouch or tray, a question sometimes we get asked is peel testing and burst testing interchangeable? And in my opinion, I would say not really. I'd say peel testing is more appropriate here because you're actually measuring the strength of your seals. You're measuring the actual force it takes to pull the seals apart, which is important for keeping your package sealed, and it gives you quantitative data on what it's like to open your package at the point of use. In a few slides, Nora is actually going to talk a little more about the detail regarding acceptance criteria for peel testing. That's also, I'll say with that for now. For burst testing, this is more for identifying weak spots or evaluating how well the seals hold up to pressure differentials. This is a good test to ensure your process is in control, or a good test if your pouches aren't breathable and may have a potential to burst at high altitude. So it's not a bad test, but I'd say for this package validation testing, that peel testing would give you more usable and relevant data.
All right, thank you, Kevin. This is Nora chiming in. So we've just discussed the various components that comprise a protocol written to satisfy the ISO 11607 guideline. Now let's discuss some elements that can help us get through the validation process with as few snags as possible. Seemingly minor details in your protocol have the ability to turn molehills into mountains, and we want to help you avoid that. Some of the most significant issues that we've seen here at Westpak can be lumped into one category of flexibility. As Kevin mentioned, stating your acceptance criteria and then meeting that criteria is the structure behind conducting a package validation test. However, there are situations where the inability to meet specific criteria doesn't necessarily jeopardize the validity of testing results. And we will go through a few of those examples now. So as Kevin discussed, one of the package validation inputs is the compression test. In this example, the target load, the target load is based on several factors, including the dimension of a shipper. If you're going to be testing to ASTM D4169, the compression formula will change based on whether your shipper is under or over 2 cubic feet. In the example that you see here, we have 2 shippers. The one on the left is 2 cubic feet, while the one on the right is slightly under 2 cubic feet, just based on that ½ dimension less. This difference of a ½ inch has an impact on the compression top load of close to 900 pounds, which is very significant. Now you have the ability to write into your protocol what you want the H, or the height factor, to be. If you know your distribution environment, and if you know that packages will not be stacked over 54 inches or 60 inches or 72, whatever that may be, you can use that specific number for H in place of 108. Now in this example, we have 2 identical shippers that, again, are 2 cubic feet. At assurance level 1, which is the most conservative and most difficult level, the safety factor, which is F, is 10, and the target top load is therefore 1,600 pounds. However, you can write into your protocol the use of assurance level 3 or 2 for compression only, and that reduces the safety factor down to 5 or 7, based on if it's assurance level 3 or 2, and that would decrease the top load down to about 800 pounds, or half the amount. Now, prior to doing this, you really should understand your distribution environment and what inputs the shipper will be subjected to. Herb, do you want to go ahead and jump in here?
Thanks, Nora. We've been asked what in the world was going through the standard writer's mind when such variables can be written into a standard, and those variables are specifically what Nora just said, either changing a assurance level or changing the dimensions of a container a very small amount, ½ an inch in this particular case. Well, remember that these are consensus standards. What does that mean? It means that a bunch of people knowledgeable in either the process, the equipment, or of general interest in the area sit around a table twice a year in this particular case, and they talk about that. In fact, they even argue about it. In fact, most of the time they argue about it. The net result is a compromise that that everyone can agree to, or the least number of people disagree with, which is more often the case. So they're not perfect. They do have some glitches in them, and this is one of the ones that we've noticed. It's simply a result of the fact that these are consensus standards, and we're not. Don't get me wrong. I'm not trying to denigrate or degrade the process standard, the writer, anything like that. All I'm saying is they exist. This kind of thing exists, and what we're trying to do is tell you about these pitfalls and how to avoid them, because some of our clients have kind of fallen into this trap before. And compression testing is probably one of the biggest failure modes of a package validation, and it's probably one of the least important functions of the secondary or tertiary package for this. So it's an easy thing to avoid, and that's exactly what Nora's trying to tell us here. Nora, back to you.
Thank you. So another snag that we see many medical device customers run into is the inflexibility within peel testing. Now this testing, often referred to as attribute testing, measures the strength of a seal, typically Tyvek and poly pouches, when they're pulled apart. Kevin talked about this earlier. Industry standard is typically a minimum seal strength of 1 pound force per 1 inch seal. Now I've queried a lot of customers over the years about why they have a minimum seal strength of 1 pound in their protocols, and I have yet to hear anyone with a basis for this number. Even 11607, which is a guidance document for the testing of sterile packages, doesn't reference the 1 pound factor. It's typically just a historical number that's been built into a company's history. Now we've seen validations fail because one seal measured 0.98 pounds force, and you're talking after a product build, after sterilization, after transit testing, accelerated aging. Once it finally gets through all that, 1 inch seal hits 0.98 pounds instead of 1 pound, and the whole validation fails. It's a bummer. There's a little known document out there called EN 868-5, that states that the minimum value for seals that have been steam sterilized is 1.5 newtons per 15 millimeter seal. Now, this translates to a minimum seal strength of 0.57 pounds for a 1-inch seal, which is typically what we use here in the Americas. And again, flexibility within your protocol is key. Do you have the ability to write into your protocol that the average seal strength for all samples is greater than 1 pound force, and an individual seal can dip below that as long as it stays above a minimum threshold, like 0.7 or 0.8 pounds? Herb, do you want to add anything here?
Those are really good points, Nora. We also find that not only a minimum strength in the seal area is important, but also a consistent strength is very important. I mean, if you're just looking at minimums, you could have 15 or 20 pounds per inch, but the simple fact is that you couldn't get the darn thing open in a area, let's call it a sterile field, where this product is being dispensed. So those who use this type of packaging consistently tell us in very clear terms they really like, and if they could, they would insist on consistent seal strength so that they can tell exactly what force it's going to take to dispense this product correctly into a sterile field. So again, not only do you need minimum strengths, but I think you need consistent strength, and that's what you should really be striving for if you really want to sell your product consistently to a happy set of clients. Nora, back to you.
Thanks, Herb. And then again, the whole point of this recommendation is to try to avoid a pitfall that may stall your product getting to market. Now, if you find yourself and your project's timeline in jeopardy of meeting your deadlines, manipulation of the accelerated aging variables may be one way to gain back some of your time to market. As Kevin alluded, accelerated aging testing allows for a package and a product to be subjected to an elevated temperature to simulate the effects of the aging process. Aging temperatures typically range from 45 to 65 C, with 55 C being the most common. And based on the Arrhenius equation, the duration of the test decreases in half for every 10-degree input or increase in the chamber temperature. Now, we've all experienced the time crunch that can come when a product launch reaches the package validation stage. You're a little bit behind schedule, it's a high-pressure situation. At this point in the process, many projects are behind schedule and looking to make up that time. And one area you were able to do so to make up that time is to work some flexibility into the aging portion of your protocol. If your protocol states an aging duration of 50 degrees C, a 1-year shelf life would take around 56 days. However, increasing that aging temperature to 60 degrees C will decrease your aging duration by 28 days. And that's 28 days that you can add back onto getting your product out to market. Now, please note, while this is a tool to speed your package validation process and speed to market, it should only be undertaken if the research has been done to ensure that the elevated temperature does not affect the glass transition rate of the products. The last thing you want to do in a high pressure and time sensitive situation is to introduce unexplained or unanticipated failures into the process. If you've done research and deem this to be an acceptable avenue to take, then you should write into your protocol the ability to adjust the aging temperature and therefore the duration without compromising the testing input. Again, it's back to the flexibility within the protocol. Now, if you're curious about how different variables may affect the aging duration, please feel free to visit our microsite, medicaldevice.testing.com, and play around with our accelerated aging calculator that's on there. Now, many of our customers have internal Tensile or Instron test machines to do internal peel testing. And while this is perfectly acceptable to use these machines and save a little bit of money, it does require an extra layer of scheduling, calibrating, report writing and reviewing, auditing, communication, etc. Consider having all the package validation testing done by your testing laboratory. This will consolidate the package validation test data into one place. It will reduce the level of communication that you have to work with. It's going to reduce the amount of documentation and paperwork that you have to organize. And in the long run, it will save you time and money to do this. And back to the point, it will speed your product back to market. Herb?
Excellent point, Nora. This does sound somewhat self-serving when a test lab says, let us do your work. The simple fact is that several instances have occurred wherein clients had a kind of a snafu in this whole process, and really were in a world of hurt. And it all happened because they were doing part of the process in-house and part of it here and part of it there. So what we urge clients to do is to consolidate that into one place. Put the pressure on one source, so you only have one button to push, and have that testing done, including the accelerated aging, real-time aging, whatever, at one source, because that then you have one place to go to make sure it's done. Now, obviously, that place has to have their act together, because you don't want to put all your eggs in one basket that's a bad basket. However, if it's done correctly, it will, in fact, speed your process to market. And we've seen the results of not doing this correctly. So that's why we put this hint in here of, do what you know best. In other words, stay in your own wheelhouse. So it's an excellent point. Thanks, Nora. Back to you.
Thanks, sir. All right, one more key point here. During the testing process, often questions arise on a project that the test lab needs answered by the medical device manufacturer. These questions include, but are not limited to, do you know the corrugated strength of the shipper, or what surface do you consider to be the base? Now, the answers to these questions will have an impact on the testing inputs and results. However, many times the answers to those questions are not readily available, and the right person needs to be tracked down to answer them. Being knowledgeable about your protocol, about your packaging, and the purpose of testing, and being able to decisively and clearly communicate those answers with your testing lab as quickly as possible will help to reduce any downtime in the validation process. And a final way that we wanted to touch on to help speed your product launch date to market is to write your protocol with the ability to adapt to unforeseen circumstances. Now, while we try to minimize the occurrence, human error, equipment error, power outages occasionally occur during the testing process. Does your protocol allow you the flexibility in the risk assessment process to move forward or to start over based on a specific situation? Does it require a blanket do-over regardless of the risk to the project? The flexibility within a protocol to make a go or no-go decision may help keep your testing timeline on schedule and, of course, to market. Now, this, of course, is provided that that interruption and that nonconformance did not have an adverse effect on the testing inputs or the testing results. Now, a testing laboratory of high-quality standards will work with you to talk through the situation and help determine the risk assessment to your project. Herb, do you want to jump in here?
Yes, Nora, thank you. One of the things that we really encourage our clients to do is to witness the testing whenever possible, and this has normally a very positive effect on answering the nuanced questions that no one ever thinks of, and it's not that we're not diligent or anyone else isn't diligent. There's always things that occur that you see exactly what's going on. You can ask questions. You can also talk about them to your management, to the FDA, to whoever questions them, much more authoritatively. So whenever possible, we encourage clients to view the actual testing. Not that you have to, sit outside the accelerated aging door for 28 days. No, that's not what I'm talking about. But the dynamic portion of it, yes. There's lots to be learned in that process. Stuff that you can never really anticipate. But it's a really good exercise, and we highly encourage it. Nora, back to you.
Great, thanks, Herb. So we've just covered 6 tips to consider when writing your test protocol that should minimize downtime in the validation process and speed your product to market. Now, as a medical device manufacturer, speed to market is one of your highest priorities. And as a testing laboratory, integrity and data is our top priority. Now, Westpak always appreciates the ability to partner with our customers to ensure that both of these priorities are accomplished for a mutually beneficial partnership. Now, speaking of the process of validating a package, this is typically considered a critical process parameter for medical device companies, and therefore the laboratory that you choose should be on your critical vendor list. Now, there's several levels of certification that a testing laboratory may obtain, and these escalating levels increase the lab's adherence to testing practices, quality procedures, and calibration standards. Now, as a medical device manufacturer, it's your job to determine what level of quality control your project requires and to align those needs with the appropriate testing laboratory. Typical certifications you can expect to find at a testing laboratory include what you see here. ISTA lab certification demonstrates that the laboratory is properly equipped to conduct ISTA package performance testing. ISO 9001 certification, that I'm sure we are all mostly familiar with, is focused on the quality management system of an organization. It tends to focus on documentation, auditing, training, nonconformances, and management's responsibility. Certification in 9001 is conducted typically through annual audits from a third-party certification body. Now, ISO 17025 accreditation process takes the 9001 certification as its foundation, and then it adds technical competence of testing and calibration. Accreditation 17025 looks not only at the quality management system, including documentation, control documents, internal audits, all those fun things, but also the technical competence of the testing engineers and the calibration engineers. Calibration standards are held to a higher level than NIST traceability, and uncertainty of measurement budgets must accompany all the calibration methodologies. Additionally, accredited labs must comply with proficiency testing, whereby blind studies are conducted, similar to round-robin studies, and those labs are ranked amongst each other. It is the highest certification that a testing or calibration lab can hold, and therefore it holds the most esteem. Now, there are a few other certifications that a laboratory may hold that you may be interested in. ISO 14001 is a standard dedicated to the reduction of waste and pollution. ISO 18001 is a standard out of Britain, and it focuses on occupational health and safety performance. And finally, ISO 1345, which I'm sure most of you are wonderfully familiar with, is typically not applicable to third-party testing laboratories as it covers the manufacturing process of devices that we do not conduct. Now, before we close, we will discuss a few tips on how to partner with your testing laboratory in order to make the best use of both your time and energy and get the product to market as fast as possible. Now, first and foremost, the customer and the testing laboratory are partners in this process. Each should take time to understand each other's processes, fears, expectations. A quick phone call would serve to set these expectations. For example, at Westpak, the process of receiving the product into our shipping and receiving area through our staging area and onto the production floor is pretty fluid and relatively quick process, assuming those shippers arrive with the proper documentation. However, if the product arrives without any traceability, valuable time and manpower is used trying to track down where the shippers came from and what they're there for and what we're supposed to do with them. This creates unnecessary delays and just adds time onto the end of the validation process. Knowing the process and the best practices of your lab will help speed your project through the pipeline. Now, at the same time, your laboratory of choice should be proactively discussing with you the urgency of your project and any challenges that we may be able to assist with. That's kind of what this slide also states. If you have specific urgencies or challenges or blind spots with your validation process, make sure you communicate those to your laboratory. The lab may have a queue or a lead time, and if you have very specific urgent requests, they may be able to work with those and get you in faster. Now, speaking of these conversations and setting expectations, it is wildly important that all the critical information be relayed to your testing laboratory. Simple factors may be overlooked, which may have an impact on the test. These include if the products are overpacked upon arrival, if specific ramp rates are needed, or if specific intensity levels are needed, just to name a few. Now, more importantly, the purpose of the testing should be clearly communicated to your test engineer, so that they have all the information that they need to process the validation through and get that product out to market. If visual inspections are to be conducted, it is important to clearly set the expectation of what you are looking for and what is important, what results you want documented. One last tip here, contact your testing laboratory early in the validation process to gauge their lead time. These early conversations may also help to identify any blind spots or potential issues in the testing schedule. Now, in line with this recommendation, ensure that your internal protocol is approved and signed off with ample time to deliver a copy to the testing laboratory. In that vein, if your protocol references other applicable company SOPs, ensure that you've also delivered those to your testing laboratory. Herb, did you want to chime in before we conclude here?
So surprisingly, I don't have any comments on that. I wanted to thank both Kevin and Nora for an excellent presentation, for putting this all together, and in a flow and in a fashion that really made a lot of sense. So no comments here. Why don't you guys close it up, and we'll see if there's any questions from our audience.
Wow, we've rendered Herb speechless. That's a first. To conclude our webinar today, again, here's a few of the things that we discussed. Kevin went over FDA requirements for package validation and a few of the ISO 11607 guidance document requirements. He went through the different sections that you typically would find in a validation protocol, went briefly through those. And then I discussed some common issues to avoid when developing your protocol. Remember, we talked a lot about flexibility and building flexibility into your protocol, what to look for when choosing your third-party testing laboratory, and then how to best work with your laboratory to speed your project through and get it out to market quickly. So that's about it for our presentation today. Greg, do we have any questions from the audience?
We got a few here. The first one is ASTM D7386 more or less stringent than D4169? Which one is the more severe of the two? Or is there an apples-to-apples comparison, or is it completely different? You guys got a comment on that one?
So sure, we always have comments. Good gracious. Even if I don't have any comment, that's a comment. The two are very different standards. They were set up for primarily the same reason, but by different groups within ASTM. It would be very difficult to hang a more or less severe handle on either one of them because they both have some flexibility in terms of their what we refer to as assurance levels. 4169 first introduced the concept of assurance levels as a way of saying, you know, if we take the distribution environment and use amplitude levels that are max, or 3 sigma, 99.4% of those measured in the environment, for all of them we overtest. So they allowed for some levels of reducing either amplitude levels or durations or both in order to make the test more suitable for the application. And to a lesser extent, 4386 does the same thing. So it's a difficult question. I don't think there's any way to really say yes or no. Remember that both of these standards are what we refer to as qualitative tests. And Westpak has kind of used the terminology of calling them a package integrity test, because they are qualitative. There are no numbers generated during the test, as opposed to a qualitative test wherein you actually generate numbers, you put transducers in the product, and you measure responses. So these are our qualitative tests, and therefore the results are going to be different. And there's going to be no numerical method of saying this one's more severe a response than that one, because we're judging the results qualitatively. Did it pass or not? So the answer to the question is, I don't know, and I don't know anyone who does know. So it's there really isn't a good answer for that one, in my opinion. Greg, back to you.
Thanks, Herb. Looking at ASTM D4169, can it be applied for electronic devices? So if you have an electronic medical device or a computer or something, can you apply that to validate, can you apply D4169 to validate your package for that?
Yeah, I don't see why not. It's really a general standard for package performance testing. The way the standard was written, which was based on empirical data, it was from sending out test samples and measuring what was actually happening in the distribution environment. So it should be representative of any product, really. So I would say yes, it's applicable to electronics as well as medical devices. Herb, did you want to say anything else?
Yeah, that's exactly right, Kevin. Think of it this way: these test protocols are designed to simulate what happens on a truck or rail car, aircraft, whatever. Do you think a truck knows or cares whether it's carrying electronic products or a bunch of vials of injectable solutions? Obviously not. Doesn't know. Okay, so the environment is the environment. So whatever you have to travel through that environment, electronics, liquids, medical devices, you name it, all gets tested the same way, simply because the environment is the same and a truck doesn't care. I'm sorry to sorry to break the news to you folks, but a truck really doesn't care. Okay, so the same procedures do apply. Greg, back to you.
Cool. Another question: could you guys talk about the different assurance levels under D4169? What can you talk about? Is the higher or lower? Why would you choose one over another?
That's an excellent question. So there's 3 assurance levels associated with ASTM D4169, and they are aptly named Assurance Level 1, 2, and 3. Assurance Level 1 is the most conservative and most difficult assurance level that there is. The drop heights are going to be higher, the compression load is going to be heavier, and the vibration input will be more intense. Pardon me. Assurance Level 2 and 3 descend a little bit in their intensity. Assurance Level 3 has much lower drops, half of the compression rate, or half of the compression load of Assurance Level 1, and a much less severe vibration input. Now that being said, it's our recommendation to kind of stay away from Assurance Level 3 unless you really need to, or unless you can justify that that is what your distribution environment is like. Now we do see a lot of medical device customers call out Assurance Level 1 with the exception of compression, and to do the compression load specifically at Assurance Level 3, because like Herb mentioned, compression tends to be one of the difficult situations, the difficult sticking points for the validation process. So that being said, we do recommend that our medical device customers stick within Assurance Level 1 or 2 if possible.
Herb, would you like to comment on that?
That's exactly right, Nora, and it's good to reinforce what she said by looking at the reason for why in the world do these things develop in the first place. And as we mentioned earlier, a little bit earlier, they are an attempt to better tune the process to the laboratory. And the process strictly is bringing the distribution environment, the hazards of that distribution environment, into the laboratory, subjecting your product package system to those hazards, and then qualitatively analyzing the result. That's the process. And what we try to do is tune that as best we can. In order to tune that, or to bring that environment into the laboratory, you got to measure it. And when you measure it, you get the a distribution curve for impacts, for vibration, for temperature, for humidity, for top load compression, for altitude, all those things. So if you want to subject it to the 3 sigma of each of those, which you can do from any particular measurement, you're going to wind up with what amounts to an overtest, because that never happens in the real environment. So in order to kind of tune that back, the people who wrote the standards came up with this idea of different assurance levels. And the standard is kind of, in my opinion, kind of weasel worded, and it says, well, if you want more assurance levels, you want more confidence in the data, things like that. And what they're really doing is what they're saying is that the distribution environment, yes, it's the same environment, but what we're trying to do is to make sure that we don't over-test by using the 99.4 or 3 sigma level of each of these hazards on all the packages all the time, because it'll never happen. Okay. So the assurance levels, I think, are a very good way to kind of tailor the inputs back to a more reasonable, more realistic level. So they're very well thought out, and they are exactly what Nora said. They're a reduction as you go. Assurance level 1, 2, and 3, they reduce the amplitude or the time or the intensity or all 3. Okay, back to you, Greg.
Cool. Thanks, Herb. Another question: what type of products or materials can you use for accelerated aging per ASTM 1980 as it applies to, or what materials can you use for accelerated aging per ASTM 1980? Is there something that you shouldn't age? Steel, plastics, those type of things. What type of materials can you use for that? Is there anything specified in that standard that you guys know of? Herb?
Let me try to tackle that. It's an interesting question, a good one. The processes winds up being fairly limited to what Arrhenius called, or those people that talk about his equation, called molecular activity. That's the exact term that's used, and it's strongly geared toward, I'm not sure it actually states this, but it's strongly geared toward organic molecules. Steel is an organic molecule. So there are the Arrhenius concept works in a relatively narrow range. I remember trying to accelerate the process of some stored food sometime, and it was a miserable failure. So you have to be pretty careful about the application of it. And in fact, the FDA is also pretty careful about it, because the standards that they use, ISO 11607, I believe strongly recommend that you use accelerated aging in concert with real-time aging. What does that mean? That means that that you have to keep checking to make sure that your 6-month, 12-month, 18-month, whatever that happens to be, accelerated and real-time aging results are virtually the same, very, very similar. So, good question. Unfortunately, there's not a real good answer for it, but what we do know is that the bodies that we have to convince of our data, namely FDA, does accept the Arrhenius concept of accelerated aging for medical devices. That much we know. Okay, Greg, back to you.
Cool. Thanks, Herb. For ISTA 7D testing, the question is, would you use those profiles for your conditioning for ASTM testing or ISTA 2A, 3A type testing for your validation protocols? Herb?
Resounding no. The 7B, which is a brand new standard, by the way, DDOG, is specifically for what's called cold chain stuff, and they are specific in terms of their application, as opposed to a much broader scope of shipping environment temperatures and humidities that standards such as D4169 and 7386 talk about. And in both cases, they do reference an ASTM standard 4332 that gives you general guidelines for testing at what are considered to be moderate and extreme temperature and humidity conditions. So I would definitely recommend 4332, which is referenced in 4169, and I believe in 7386 as well, for your temperature and humidity conditioning. I would not rely on the ISTA 7D data or process. Greg,
Cool.
Back to you.
Thanks, Herb. Our last question here, we're running short of time. If we didn't get to your question, we'll get to it. We'll get back to you after the webinar. But regarding assurance levels, have you heard of anything from the FDA feedback, pushing back regarding the assurance levels used in tests? Has anybody heard anything FDA-wise on that?
I haven't heard anything about the FDA pushing back, but we did get that comment in the previous webinar that that they are, I think it's ASTM is reevaluating the use of assurance levels. So it does seem like there's some kicking under the covers going on there with respect to those. So I think time will tell and where those go to. And Westpak does keep its ear to the ground. We have a couple members on the different ASTM and ISTA committees, so you know, aware of these things as they come out. But that's a great question. In fact, all the questions were great today. I'm happy and impressed.
Cool. Nora, Kevin, Herb, thanks for the presentation today.
Thank you.
If anybody else has any other questions, you can submit them to projects@westpak.com. If you missed anything or would like to listen to the webinar again, you can find it at our website at westpak.com under the Events tab. The webinar should be uploaded by next Wednesday. All people who were registered for this webinar will receive an email within 5 days with a copy of the recording and a link to download the slides. Check our website for upcoming events for under upcoming events for our next webinar. If there are any other webinars you'd like to see us offer or have any other suggestions, please email them to projects@westpak.com. We'll be sending out a short survey following the webinar. Please fill it out, as we are always looking to improve the process. Thank you all for attending. I'm Greg Schwinghammer. Make it a great day.